Okay, gather around everybody. We are starting our final unit of the school year. This is so exciting. It is June 4th. This is an introduction to oxidation and reduction. And I've got here my potato clock. And we've got the time ticking away as this year is approaching its end. The way this potato clock works will be explained by the end of this unit. Okay, our focus in this unit is all about the electrons. We're going to be tracking electrons. Oxidation reduction refers to types of chemical reactions in which one atom loses an electron and another atom is there to gain the electron. The loss and gain of electrons is an interdependent relationship, and it is known as a redox reaction. To explain what redox reactions are, we have a sentence here. It's Leo the lion goes grr. Leo refers to the loss of electrons is oxidation, and grr refers to the gain of electrons is reduction. So, one species, one atom will lose an electron, and one atom is there to gain that electron. The atom that loses an electron is said to be oxidized or undergoing oxidation. The atom that is there to gain the electron is said to be reduced or undergoing reduction. So, how can we identify the oxidation states of atoms? I hope this is sounding a little familiar to you because in our unit on writing formulas, we had to use the oxidation states of elements and the oxidation states of polyatomic ions to help us. So we need our periodic table because the selected oxidation states are written in the upper right-hand corner of individual atoms. And we need table E because these selected polyatomic ions have a net overall charge on them. And when we assign oxidation numbers, we need to keep the overall charge of the polyatomic ion in mind. So I've got here our UpGo book, and I just want to highlight to you that on pages 140 and 141, we've got the rules for assigning oxidation numbers. I've highlighted a few items in here as I go through these rules very briefly. First of all, the oxidation number of each atom in free elements is always 0. If I have a diatomic element like oxygen, O2, that oxidation state is 0. The next rule, the oxidation numbers of ions are the same as the charge on the ion. Group 1 metals only form +1 ions, as you can see here, +1. Group 2 metals only form +2 ions. Oxygen, the vast majority of the time, oxygen will have a -2 oxidation number, as shown here. There are a few exceptions, such as with peroxides and sodium oxides. Hydrogen is unique in that it could be +1 or -1. The majority of the time, hydrogen takes on a +1 oxidation state, but when it is bonded to metals, as in a metal hydride, hydrogen will take on a -1 charge. Finally, the sum of the oxidation numbers in a compound is always 0, and the sum of the oxidation numbers in a polyatomic ion is always equal to the charge on that ion. First, we'll look at examples of oxidation states for atoms in a compound. So we know we want a net 0 charge overall. Looking at sodium chloride, Sodium, being an alkali metal, has a +1 oxidation state. Chlorine, you'll notice, has 4 oxidation state possibilities. But hopefully you'll recall from our formulas unit that the cation is bonded to an anion, therefore that chlorine must be -1. Looking at our second example, magnesium is a +2. The majority of the time, oxygen is going to be a -2, and we have that. Example number 3, this is a free element. Its oxidation state will always be 0. And our fourth example here for water, we have oxygen is a -2. The hydrogen is going to be a +1. Notice here, right, we have 2 hydrogens at a +1. That has a net charge of +2. And the oxygen has a net charge of -2. I have a couple more examples. These could be a little more challenging and therefore a little more fun. We have our hydrogen. We know hydrogen is +1. But now we have nitrogen and oxygen. We have 2 other atoms to consider here. Nitrogen has lots of oxidation states. I don't want to guess which one that is yet. Let's go to oxygen, which has to be a -2. So what I do is I make little brackets. I have 3 oxygens at a -2. That is a -6. I have that 1 hydrogen at a +1. That's +1. This nitrogen must have a +5 charge in order to get a net 0 charge. I write that +5 there, and I always double check, yep, that is one of the options there, so I've done this correct. Let's look at iron bonding with that oxygen here. Oxygen, -2, and there are 3 of them. That is a -6 charge. Now, iron could be a +2 or a +3. Well, all I know is we need to have a +6 overall charge here to make this a net 0 charge. I have 2 irons. 2 times +3 gives us that +6. So the oxidation state must be +3 in that case. What about oxidation states for atoms in a polyatomic ion? As I mentioned before, the polyatomic ions have a net charge that you can find on table E. So we don't want these oxidation states to add up to 0. We want our oxidation states to make the overall cluster of atoms have a -2 charge, or a -1 charge. So when we look here, we know that oxygen has a -2 charge on its own, and we have one of them, -2 charge. We know that hydrogen always has a +1 charge unless it's bonded with a metal. And we have 1 hydrogen here, it's +1. Notice that these are the proper oxidation states. It doesn't add up to 0. Let's look at the sulfate ion. We want an overall -2 charge. How are we going to do that? When we look at sulfur, there's 3 possible oxidation states. So I'm going to start with oxygen. Oxygen is a -2. I have 4 oxygens at a -2. That gives me an overall -8 charge. I want my sulfur to have a positive charge, but I want an overall -2 charge for this cluster. Therefore, this must be +6. And I write it up here. And I can check, and you'll see that that is one of the options for sulfur. So that is correct. Let's look at the dichromate ion example. It's an overall -2 charge. Chromium has 3 possible oxidation states. So we're going to start with oxygen because we know that that's a -2. And we have 7 of those. That's a -14 overall charge. Well, chromium, there's 2 atoms of chromium, and this charge must have an overall +12. Why? Because I want an overall -2 charge. I have 2 chromiums. Their oxidation state must equal overall a +12. That makes this a +6. That concludes this lesson. I hope you enjoyed it. Have a great day. Bye.